Hello, and welcome to the AOPA Air Safety Institute's safety webinar, Forced Landings, A Plan to Survive. My name is John Collins, and I'm the Manager of Aviation Safety Programs for the AOPA Air Safety Institute and your host for this webinar. A few housekeeping items before we begin. Please make sure you've muted your microphones and also that you've turned your volume up loud. We're going to have some video later on in the segment, and it's a little soft, so please make sure it's up when it comes time for that. If you have any technical issues, we will not be able to troubleshoot them during the webinar, but we found that audio issues and usually other issues can be solved by logging out and logging back in. We will take questions throughout the presentation and answer as many as we can at the end of the webinar. To submit a question, use the question mark on your PC or laptop control panel, which is located on the right side of your screen, or the question mark at the top of your screen on your tablet or smartphone to submit them. Once you've submitted them, you may need to click on that again to make it disappear so you can see the rest of the presentation. During this opening section and the question and answer period, our webcams will be available. For those of you on computers and tablets, we should appear at the top of your screen. If you're watching this on a smartphone, you may need to swipe left or right to view the webcams as necessary. Wings credit is available for the webinar, and if you signed up for this webinar with your FAA Wings account email, that's your FAAsafety.gov address, the Wings credit will be credited automatically to your account within 7 days. A recording of this webinar will be available via the Air Safety Institute webpage, so if you have to duck out early or if you want to have friends and family that haven't had a chance to look at it with you, review it, you can go to www.airsafetyinstitute.org, and you can see it there. You will also receive an email with a direct link to the recording. If you missed any of our previous webinars, you can find those at webinars.aopa.org. For those of you who are using the AOPA Pilot Passport, which is a part of the AOPA app, attendance at this webinar will earn you the Pilot Passport ASI webinar badge for August and 1,000 points. We'll have more on that at the end of the webinar, along with some screenshots so you know where to find the place to submit the credit at the end. Our presenter for tonight for our webinar is Sam Huffstetler. He's an airline captain and active CFI, a former U.S. Air Force fighter pilot, and he's presented for ASI at the Pilot Proficiency Center at AirVenture in 2018 and 2019. Thanks for joining me tonight, Sam. The floor is yours.
Thanks, John. I really appreciate it. And thanks to everybody for joining us this evening. I hope that everybody can learn something from this, including myself. I always learn something when I'm working through these presentations, and I hope to pass that on with you. And I look forward to your questions at the end of the seminar when we open it up for the questions and the answers. So clearly that we train for a lot of scenarios. We train every week, but we don't necessarily think about the actual process of conducting a forced landing. So there are quite a few different scenarios or options for these forced landings that we have to think about, and that's what we're trying to do today. That's what we're going to go over. So we're looking at this objective. It's a rather lofty objective, and I'm going to give you a couple of seconds to read through this. I don't like to read slides, so I'm not going to read the slides to you. I'll emphasize a few things just to bring them out to make sure that you know what we're trying to work on here. But the main point, the main 3 points of these objectives are to have a plan, to come up with a plan, to train to that plan, and then when the time comes, you'll be able to make the decisions and process the emergency and actually make it happen the way you want it to happen, the way you planned for that to happen. And let's talk a little bit about the overall philosophy. When I was a kid, my father brought this up to me when I was learning how to drive, and that is, imagine yourself driving down a narrow mountain road, and off to the right is a huge drop off, 1,000-foot sheer cliff. Off to the left, off the road, are tall trees, impassable. There's no shoulder over there. Coming at me, 180 out, is a semi truck. It's closing in. We're going to pass comfortably, but as it almost arrives to me, a deer runs out in front of both of us. what do you do? And so if you go right, you go off, you die. If you go left, you go into the trees, or you go into the lane, you get hit by the truck. Well, the answer is, it's not a palatable answer, but you're going to wind up having to go straight ahead and maybe hit that deer. The thought process is that if you are able to think with me today and come up with some ideas of what to do in a very unpalatable situation, well, then maybe you'll be able to come through when the time comes and actually execute that process just a little bit better. So that's our objective for the day. So as a quick refresher on my background, I am a CFI II. I flew, fortunately, in the Air Force. I got to fly fighters for 3 tours in F-15 as an instructor pilot, also instructing in the AT-38. And I got hired in 2002 at a major airline in New York City, and fly as a check airman on the Airbus. And one of my proudest accomplishments is I'm a co-owner of that little blue RV6 there. And so for anybody who thinks flying for the airlines is glamorous, well, just consider that I share an apartment in New York with 9 other guys, and we have 1 bathroom. So it's not always so glamorous. But let's get to the topic at hand, and that is, what are we going to talk about today? So again, if there are areas that I don't touch on today, keep them in mind, and we'll talk about them later during the Q&A. Now, AOPA has a long list of pre-recorded and really good webinars that you can go to after the fact. You just search YouTube, or rather search the AOP website, and you'll be able to find those webinars at will. And now you'll find one that'll be of great interest. It's called After the Crash, and that's was done by John Collins, the fellow who introduced me tonight. And it will tell you all kinds of survival tips for what to do after what we talk about tonight happens. So we're not going to touch on survival tips as such. So let's get on with the engine failure ideas. What are the chances of this happening to you? So I think this is going to be really interesting. We've got about 470 people online right now who are attending this webinar. I think it would be very interesting to find out how many people have had engine failures that led to forced landings. So John's going to open up a poll to allow you to go out, and I'm going to see if I can get rid of this off my computer. There we go. We're going to see how many of you have had forced landings that wound up leading or resulted from an engine failure. We'll talk about it at the very end. So we are talking about forced landings, not precautionary landings. Forced landings are a result of an engine failure. Precautionary landings would have taken place under a bit of control because of other complications that are impending, such as maybe impending fuel starvation or weather that's closing in, or some kind of malfunction on the aircraft that means you have to land right away. So we're dealing again with the forced landings without power, and remember that ditchings are also a forced landing that happens in the water. So we're not really making much of a differentiation on those. So if you take a look at the NTSB numbers, you see that they give the overall listing of causes for aviation accidents there. And of course, we have the usual number 1 and number 2 for loss of control and controlled flight into terrain. But number 3 and 4 are what we are talking about. Clearly, a power plant failure as number 3, and number 4, fuel related leading to a power plant failure. So it's also interesting to notice that of all of these options, at least 9 of these options, these number 3 and 4 are the only 2 that give us options to really control our fate, because this is a very controllable situation once you lose that engine out there. Now, of course, we always want to make sure that we stay away from the idea of running out of fuel, because there just aren't enough words in the English language to describe why you ran out of fuel. So we're going to put that to bed and just talk more about what happens really when you wind up losing that engine. Again, how often does this happen? Well, this comes from the 2019 NAL report, which looks at aircraft accidents all the way through about 2016. As you can see here, about 72% of all accidents are pilot related, but you see about 18% of accidents are mechanical or unknowns. And so our fuel, and power plant failures are listed in that 17.9% mechanical number. Let's go back here and look a little bit further, or a little bit more in depth. Again, from the Null report, we look at the types of mechanical accidents, and you see under the power plant, we have about 81, and the fuel system, we have about 35. You put those together, and that gives you out of 1,214 accidents that took place in 2016, it gives you about 116 that were due to power plant or fuel system issues. Now, that's about 9.5% of all accidents. Now, the reason that it's very difficult to come up with these numbers is that not all engine failures are reported. They do not meet NTSB Part 830 reporting requirements unless there is substantial damage done to the aircraft, a personal injury, or of course, if it's requested by the NTSB. So that's one reason why we're looking at this poll, to see just how many people of this group have had these accidents. Now, on this slide also, you see the ATSB acronym there. That stands for the Australian Transportation Safety Board. They do a lot of research on aircraft safety, and their numbers in 2016 came up with just basically 13 per 100,000 flight hours, 13 failures per that flight hour area or period within the Lycoming and Continental grouping of engines. 15 per 100,000 for the Rotax. If you fly experimental aircraft, you're familiar with the term the Jabiru engines. They have a much higher engine failure rate. I don't have that number on the screen, but it approaches 30 per 100,000 flight hours. But if you're happy enough and lucky enough to fly behind a PT6, it's bulletproof. The thing only fails 0.15 times per 100,000 flight hours. So if you have about 800,000 hours, or dollars rather, you're in good shape. You can go buy a PT6. So what happens when you do have that engine failure? Well, it is human nature to be startled, and there is absolutely nothing you can do to train yourself away from that startle response. You can train what happens after it, but that startle response will stay with you regardless of how much you try to plan for it. It's really interesting in that when I was doing research for this project, I went through the NASA databases and all the research they did, and they have a ton of research on the effects of sound and sudden sound on astronauts and how that causes stress and startle responses. In this case, for us, it's the lack of sound. That engine has gone to pot, and you have no engine noise in front of you, and now you've got to deal with it. I found this quote within the NASA study on response times to be very interesting, in that if you have been conditioned during training to expect to find a good landing area, and you startle yourself, or you have rather an engine failure, and you are now startled as you approach the emergency process, you're very likely to ignore all the airmanship that you've ever learned to avoid aircraft damage. And aircraft damage really is very likely. So we have a video that I want to try to show you here. Give me just a second and we'll try to get that going for you. Okay, well, it looks like a video is not working for us today. I'm sorry that I couldn't get that going for us. I'm going to keep going here. The video was of a Cessna 182 engine failure in Palm Springs, California, and the pilot in question, David Ramey, simply had one thing to say, is that for the first 5 seconds after the engine failure at night, he just couldn't believe it, and he couldn't believe it was happening to him. And once he got past that 5-second period, he was good to go. Okay, so once that happens, what are the priorities for you if you have an engine failure? Well, we've heard these a million times before, aviate, navigate, and communicate. And if you don't do those three in that order, you are very likely not to have a successful outcome. Now, the bullet on the bottom is very important. It is not your job to keep the aircraft from being damaged or destroyed in this case. You have to have a shift in your mental prioritization because it is very important for you to survive this and for your passengers to survive this. And if it takes using the physical aspects of your aircraft and damaging it just to get everybody down safely, then that's what your job is. So let's talk specifics about how to make this happen. Aviate. Yes, you're going to level your wings, you're going to roll out of your bank, and you're going to pitch for that best glide speed. Now, all day today, just for example purposes, I'm going to talk about a Cessna 172 that has a best glide speed of 65 knots. Obviously, your aircraft might have a different glide speed out there. But once you pitch for that best glide speed, you trim it up to that glide speed, take a breath, take a deep breath or two, and now you're going to make an assessment. You have a decision to make. Are you going to land right away, or are you going to attempt a restart? So how do you know? What do you do to make this decision? Well, actually, it's a lot easier than you think. You have to just figure how much time do you have and how much headroom do you have? How much bandwidth do you have in your mind to take care of the emergency vice, just fly the airplane and put it on the ground? Well, let's take a look at that. How much time do you have in the case of an emergency? The rule of thumb for most typical GA aircraft with a 9-to-1 glide ratio is that you take your altitude in thousands, then you multiply it by 2. That gives you the time. For the altitude, well, a little less. Again, the altitude in thousands times 1.5 gives you the distance that you'll be able to glide out there. So the concept is actually pretty clear. Of course, the lower you are, the fewer options you have. So again, as you see here on the bottom of the slide, if you're having an engine failure at 2,000 feet, it gives you about 4 minutes before you reach the ground and about a 3-mile glide range. But of course, if you have an engine failure at 500 feet, it only gives you about 1 minute time at about 1.5 miles of gliding range, and it's going to be a very busy minute indeed. So this brings into focus the idea of maintaining VY, which is your best climb rate, on takeoff, at least up to the pattern altitude. Higher is okay too, and then you can transition to your faster cruise climb speed. That allows you to get away from the ground quicker and have more options under your belt, if you will, should you run into an engine problem. And keep in mind that while you might have 5 minutes of time while you're gliding, that last minute is going to be filled with aviating. You're not going to have a whole lot of mental bandwidth in that last minute to do very much other than concentrate on your landing area and make sure that you land correctly. Most aircraft flight manuals or pilot operating handbooks have these charts, and they simply show the quick illustration of what we were just talking about in terms of your altitude and the amount of distance that you can glide and the time that you might have. Again, your particular aircraft may have a slightly different glide ratio, which is why you want to take a look in that chart. So what happens if you don't have much time? I teach my students that if you have 1,000 foot of altitude or less below your fanny, then it's time to concentrate on landing the aircraft. So again, you're going to pitch for that best glide speed and you're going to trim the aircraft. You're going to pick out that best landing site. You are going to stick with it. You need to stick with that landing site because changing it puts in too many variables. You don't have many engine restart options available because of the time. If you do have some extra bandwidth, you might be able to swap tanks or turn on a fuel pump or throw on a carb heat, but otherwise, your basic option is to secure yourself and the passengers. Maybe you can communicate a quick mayday if possible on the frequency that you're on, and then, and this is critical, before you touch down on any surface, you slow down to a reasonable but minimum controllable airspeed prior to touchdown. Okay, what happens if I'm above 1,000 feet? And in this case, I have time and brain cells available, and I'm able to figure things out. Well, okay, I'm going to pitch and trim the aircraft for the best glide that I have possible. And I'm going to take a preliminary look and see where I can put the aircraft down, and I'm going to turn in that direction. And I'm going to use now my visual acuity or the nearest function on my avionics to determine where I might be able to take the aircraft and see if there's a runway somewhere close. In this case, you might also need to throw in a Mayday call and advise ATC of your problem before you go through the restart process. Now, the restart memory items checklist or flow bullet there is bulletized for a reason. It's summarized for a reason because what works for one person doesn't work for another one. The memory item is great. We used to call it boldface in the Air Force. It's basically you pull out of your brain the basics of how to fly the aircraft and how to get the airplane running again. Unfortunately, your memory is the worst possible part of your brain or your body under high stress environments. So if you have a checklist, I would suggest that using that checklist is the best way of go. If you have the ability to modify your own checklist, I would suggest you tab it, index it, or another way, make sure that that emergency section of that checklist is easy to find. You can always reformat your own checklist as long as you include what the manufacturer had in there to begin with. Then just remember the basics there. Your GAS acronym for gas, air, and spark simply means that, yeah, you want to take care of switching tanks, check the mixture full rich, make sure your fuel pump is on if you have one, pull the carb heat out, get the mags on and maybe switch them a little bit, and even put the primer in position where you could put a little bit of gas in the engine that way. I had a friend who had an engine failure at low altitude because he ingested a bird, and the only way he cleared the engine at low altitude was to prime it a couple of times. The engine coughed, blew the bird out of the engine intake, and he kept flying again. So just something else to throw in your bag of tricks. All right, so we have gone through the first two steps, and now it's time to navigate. So, I'm sorry, the first step, and now it's time to navigate. So, what is optimum here, of course, and what we all crave are open fields. So when you take a look at a field, take a look at the approach path to make sure you don't have any tall trees or obstructions that lead to that field. Take a look at the furrows to see if the furrows are lining up in your direction of landing. If the furrows are perpendicular to your approach, it's much easier, especially on a fixed gear aircraft, to hit a furrow and drag the airplane over on its back. Check for power lines, and they may or may not be very easy to see, but what will be easy to see are wet areas. If you have a wet area and you're in a retractable gear airplane, well, you're probably going to need to leave the gear up. But if you're in a fixed gear airplane, you need to make the best saw field landing you've ever made, because that high drag area within that wet zone of a field is going to cause the airplane to decelerate very quickly. And again, it might put you on your back. The wind direction is always important, and I would always suggest that you take a look on a route of flight to see what the surface winds are on that route of flight, just so you have an idea, if you have an engine problem, of what direction would be optimum for you to be able to land into. Now, you see roads there, you see the acronym ARHW. That stands for all roads have wires, and it is absolutely true. And in most cases, you're never going to see those wires until you're right on them. So just bear in mind that if you are on a road or looking at a road to land on, you're going to look for the biggest one around, and of course, look for those obstructions. We'll talk about landing in trees rather, a little bit later on, but we do definitely want to avoid buildings and structures for obvious reasons out there. We'll talk about other suburban or urban landing options when we get just a little bit further in the presentation. What if you have an engine failure while you're flying IMC? Well, if there are no other options for you out there and you're truly IMC when you have that engine failure, well, the first step is level your wings, slow to your best glide speed, trim the airplane, take a couple of deep breaths, and just start to descend on course. But we'll talk about follow-on options on a later slide here. The third element, of course, is to communicate, to get your word out with ATC and see if they can give you a hand. Now, none of us really relish the idea of using the term Mayday, 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 but I'll tell you that the term is exactly what ICAO wants, it's what the FAA wants, and it will get you the attention you deserve. My initial instructor was named Luke Wilson. Luke Wilson said if I had to declare an emergency on the radio, that I should count to 10 out loud in the cockpit before I keyed the mic, because when I did that, I would sound pretty calm and I would act pretty calm once I keyed the radio. That's actually not a bad piece of advice out there. Remember that if you do declare an emergency, the FAA is not going to come chasing after you for paperwork. They may call you to find out what happened, but certainly ATC is going to drop everything and they're going to help you out with the closest possible airport, weather, frequencies, and other options out there. And if you use the Mayday term, everybody else on the frequency is going to shut up because they want to hear what's going to happen next. So that's a good term to keep in mind. If you happen to use 121.5 as a standby frequency and you are not using flight following or IFR center or local controllers, in other words, if you're not in contact with anyone else, switch to 121.5, call Mayday, and be prepared in the United States for multiple airliners to call you back, because all airline crews these days monitor 121.5. So all I would suggest for you is to, when you call Mayday on 121.5, if you choose to do so, just pick the one that sounds the clearest, use his name of his airline, such as American, and tell him to stand by the copy. And everybody else will wait for you to make your call. Now, I talk about finding present position. Now let's talk about that in just a couple minutes, and I'll give you an idea of how best to find that. Now, we talked about landing under control, and I'll tell you that in my previous life as a fighter pilot, we used to say speed is life, because you had to have a certain amount of speed to be able to land fly the airplane against the opponent and maintain your energy. In our case, you want to have the perfect speed that will allow you to land at just over your minimum controllable airspeed, so that you can dissipate what energy you have in a very controllable fashion. So your best glide speed that you're going to achieve once you have an engine failure is not your best impact speed. It is the best speed that will give you the best distance while you're descending without power. So if you slow down, that's not going to make you go further towards another airport. It's merely going to slow your descent, but you'll go a lesser distance. Now, how heavy you are also does not determine how far you go. It does determine your angle of attack, and more likely your actual best glide speed. Most of us use a single speed to determine your best glide speed. So for all practical purposes, let's just drop weight out of the consideration, except to know that weight does impact stall speed. And we'll talk about stall speed and its relationship to your touchdown speed in just a moment. You should know what your minimum controllable airspeed is above a stall with the power off. And if you don't know that, go out and practice it next time. So you need to know that when your speed is doubled, your energy is quadrupled. So what this means really is that your total energy that has to be dissipated by your aircraft and by your bodies inside that aircraft is a function of the square of your airspeed. So this is from the Aircraft Flying Handbook. It shows an aircraft landing on the left at 50 miles per hour and enduring a 9G deceleration, which I am told that general aviation aircraft are developed to be able to handle without significant structural damage. When I say significant structural damage, it should allow you to remain alive within the cockpit. So as you can see, at a 50-mile-an-hour 9G deceleration, it only takes a little less than 10 feet to get slowed down. If you're at 100 miles an hour, well, it's not linear. It actually takes almost 38 feet at a 9G deceleration to get slowed down, and that can hurt you. So what does this really mean? It means that if you are in a 172 and the aircraft is gliding at 65, but it stalls at 50, let's assume that you're going to slow to 55 before you touch the trees or the bushes or just the grass out there. If you slow down to 55 knots, it reduces your overall energy by 28%, than if you were still maintaining 65 knots. So if you touch down at 55 knots with a headwind, a 10 knot headwind, which is easy to see. So that, of course, that gives you that 45 knots ground speed. It reduces that total energy by 52% from that 65 knot no wind glide. Now, the other way is if you touch down at 80, maybe downwind, maybe a little fast, man, that increases your total energy by 1/2, and that is unacceptable. Now, the FAA has long taught, and instructors have long taught, that you can't do the impossible turn, which means you cannot turn around from too low of an altitude after takeoff and return to the airport. But the FAA also says that CFIs now are to teach emergency turnbacks, and you can see the language there on the bottom on what emergency turnbacks really mean. So what we're really talking about is emergency turnbacks versus the impossible turn. Here's the description from the FAA Flying Handbook, and it's a little bit laborious, but essentially it just means that if your engine fails at 300 feet above the ground, after a 4-second startle time, the aircraft pilot elects to turn back using a standard rate turn. Well, if he does this, the aircraft descends, of course, without power and impacts the ground before you ever make the 180-degree mark. So that impossible turn, under those conditions, it would lead to tragedy. But clearly, there is an altitude and an airspeed from which you may elect to return to the airport. So what's the turn radius at other bank angles other than a standard rate turn? How much turn is required to get back there? And how much time does it take? Well, let's take a look at that. Now, I ran the numbers, and I'm not going to go through the math in public here, but at a 30-degree bank, it gives you a 650 foot turn radius, and it gives you a turn rate of about 10 degrees per second. And it takes, as you see, 24 seconds to turn back 240 degrees. And as you saw from that last slide, if you turn 180 degrees in this situation, you're not going to make it back to the airport environment. You have to turn further than 180 degrees to actually make it back to either the runway or the clear areas surrounding the runways at an airport. If you go to 45 degrees bank, the radius obviously decreases. Again, not quite a linear function, but it's about 2/3 of what you had at a 30-degree bank. And it gives you a possibility of getting back to that airport. Remember, at 30 degrees of bank and 160 knots, a 747 is going to have the very same turn radius as an RV-6. So this is not aircraft dependent. It's just dependent on your angle of bank and your airspeed. So we know that altitude and speed are critical. So really, what angle of bank and airspeed should use for this emergency turnback? Well, okay, we thought about the angle of bank, but what's going to happen to your airspeed with that increased angle of bank? Now, again, no math in public, but the stall speed is increased by the square root of the load factor there. So if you're in a 30-degree bank, you're looking at increasing your stall speed only incrementally. It goes from 50 to 53 knots, assuming a 50-knot stall speed. If you go to a 45-degree bank, now your load factor is increasing, so your actual stall speed in a level turn goes up to 60 knots. Okay, with the best glide speed of 65, well, you're getting kind of close to your stall speed, but it's doable. However, if you go to a 60-degree bank, oh my goodness, the stall speed goes up to 71 knots, which is clearly not a good plan for any of us because it's well below your max glide speed. So you would have to compensate by staying faster, which of course would mean that you're descending faster too. So I drew a quick diagram here to scale with the lateral distance there to illustrate how far off the runway you would be if you used a 30-degree bank with 65 knots. Now, you will see on the next slide that that actually is a pretty significant deviation when you look at a real airport out there. That 30-degree bank at the 180-degree turn point is clearly over a huge stand of trees, and you would have to angle back to that runway to get to a nice, safe landing surface there. Now, the FAA recommends that when you do these emergency turnbacks, you have a 25% fudge factor, a safety factor. So this turnback at 700 feet really should be accomplished at 875 feet to give yourself a little bit of slop and be able to get back to that airport. I ran the numbers also for 45 degrees of bank and 65 knots, and those turn circles and turn radius actually kept you over the clear area just to the south of that runway 7 there at the Newport News Airport. Now, we talked about craft survivability earlier, but let's talk about the major factors that are going to play into keeping you safe there. These are all simple, common sense elements, but they have to be remembered. You've got to remember and practice these to be able to actually go do this if you have an emergency. So the touchdown speed is the very first thing that you have to remember for the reasons we just explained. Now, wings level. Wings level is very important, especially if you land on some other obstruction such as brush or trees, because that way the aircraft structure will symmetrically accept the deceleration and not cartwheel the aircraft there. We'll talk about fire potential here in just a few moments, but it is important that before you touch down, you probably do need to turn off your master and your mags. The fire potential numbers are substantial in terms of fatalities, but fire only happens in about 4% of all forced landings. They do figure in 22% of the fatalities. So it is important to try to slow the aircraft down and turn off those ignition sources. Let's look at the overall numbers here for accidents to see actually what lethality these accidents will provide. As you see here, looking in the middle, the mechanical lethality in terms of the accidents is only 13.6%. And power loss in the bottom yellow segment is 12.5%. Now, I say only, that's significant, but what we're really saying here is that the odds are in your favor. You have an 80 to 85% chance of surviving this case in almost every category of airplane. This is an experimental category chart, but the normal category aircraft also have similar numbers out here. If you take a look at day VMC numbers, the number of fatal accidents for mechanical accidents is only 8.6%. Night VMC, wow, only 12.5% of those are fatal. So you have about an 87 to 88% chance of surviving a night VMC engine failure. Those are tremendous numbers. The odds are in your favor in this case. So what are we going to do in terms of landing on land? Well, we mentioned earlier issues about furrows and power lines and knowing that all roads have wires. Remember that interstates do have overpasses, signs, and electrical power lines as well as vehicles. You need to make the decision on whether you want to land with or against traffic. Most of the successful landings that I've seen anecdotally via video has been with aircraft landing with the vehicles, even if the wind was not perfectly on its nose there. In most cases, you want to have the flaps fully deployed to give yourself the greatest lift and the ability to land at a slow, controllable speed. If you have a retractable gear airplane, in most cases, roads and hard surfaces provide the best option for leaving the gear down. Again, water or wet surfaces means you probably want to leave the gear up there. You do want to consider the length of the field that you want to land on and the state of the vegetation. Corn and other tall vegetation will slow your aircraft down quite rapidly. You do want to have an aim point, and that aim point for any open field ought to be 1/3 to 1/2 down the length of that field. That will give you the option of undershooting or overshooting that field. Now, the FAA's advice for landing in trees says to land in the normal configuration. Of course, you're landing into the wind to reduce that overall energy on your aircraft, and they want you to hang that aircraft. You just basically fly at the slowest possible speed into the treetops with the nose as high as possible. And the FAA, in their wisdom, says to avoid the large trees and the trunks. Well, okay, we're going to do our best to do that. But they do have a good idea in that the low and dense foliage is better, probably because it gives you a chance to slow down, lower closer to the ground rather than high. And again, you want to be as symmetrical as possible, which means you've got to be under control, which means you have to maintain a reasonable energy state just before you touch down. Water. Everybody fears water. I would never want to do a water landing, but I will tell you that a water landing will typically have initial impact forces that are less than what you have on land. The second impact is typically a little more hard and the quick deceleration. Again, the symmetrical touchdown is always best, but the FAA recommends you do not put down full flaps when landing in the water, because upon first contact with the water, one of those flaps may be damaged to cause the aircraft to go out of control and hit the water in an asymmetrical way. So limit your flap extension. You do want to land parallel to the swells, not necessarily into the wind. This is about the only case where you do not want to land directly in the wind to reduce your energy, because if you land parallel to the swells, it's more likely that your deceleration will be normal. Now, the FAA says that aircraft normally float initially. I have not seen that from my anecdotal research there, but I will tell you that we do know that fixed gear aircraft are susceptible to flipping. However, fixed gear aircraft are very successful in ditching. The number of lethal incidents for fixed gear aircraft are actually pretty low, around 22% there. You'll need to talk, or rather read, your aircraft manual to determine whether you want to leave the doors or canopy cracked open, because sometimes manufacturers make these doors and canopies an integral part of the aircraft structure. So think that one through by reading through your own manual. You may also want to invest in a cheap canopy or windscreen cracking or breaking tool. They can be had for $15 and would give you a very good option for getting out of that aircraft. Night and IMC is a fearsome time to have an engine failure, but again, you're going to maintain your aircraft control. You're going to slow to your best glide. You're going to trim that aircraft to maintain that glide. Take a couple of breaths, turn the lights on. Now start using your available resources. You probably are in touch with ATC. Use them. Use your nearest airport function or terrain function on that GPS to be able to find a place that you can go land. Now, lighted areas are generally cities, and lighted areas may not be a good place to try to put your aircraft down, because they do consist of houses, power lines, and the like. The dark areas are probably where you want to head towards. If you know that there is an open land there, of course you're going to head that way. And most of us are not that lucky. If you know there's water out there, well, frankly, a water ditching is probably preferable to landing in a major metropolitan area. Again, the night survivability numbers are actually pretty high. Night BMC arrivals are about 27%. My number was wrong earlier, but that means you have about a 73% chance of surviving that night BMC encounter with an engine failure. Again, those are really good odds for you. Now, the NTSB doesn't have a lot of numbers in terms of post-impact fire. However, there were good numbers that came out of the Canadians. And the Canadians discovered that the post-impact fire numbers, as I stated earlier, were about only 4% of overall crashes. However, they did result in 22% of the overall fatalities that happen in aircraft accidents in Canada. So again, reducing the chances are a pretty doggone important thing for you there. So shutting off your fuel, turning off your mags, turning off your master are all good things to remember. And remember that the smoke is the real killer if you do have a fire. So getting out of the aircraft as soon as possible is important. If you have a halon fire extinguisher, immediately after the aircraft comes to a halt, throw that halon onto the fire behind the panel or wherever you see it, and that extinguisher makes a very good battering ram to knock out windows and get your exits to open out there. So we talk about the possibilities of being found after you're on the ground. The USAF Rescue Coordination Center is based down in Florida, and they help coordinate the efforts of all the assets, including the CAP. Now, the CAP has the largest fleet of civilian aircraft in the world, about 560 airplanes, and over 30,000 volunteers. They also have a tremendous capability when it comes to search and rescue, and something called cell phone forensics are leading the way. So 92% of all incidents that are reported to the Rescue Coordination Center, which include water and hikers, are resolved via the phone or internet. But when it comes down to actual missions, many missions are helped quite a bit by the fact that the pilots have either filed flight plans, have used flight following, or have a 406 megahertz beacon out there. So let's talk a little bit about beacons. I'm going to skip over the survival kit and let you look at John Collins' webinar for that details for that one. The 406 ELT has a tremendous capability because all of them now will transmit a GPS position. And that GPS position will actually drive the location precision of that beacon down to about 30 meters versus a 121.5 ELT of about 12 to 14 nautical miles. Now, remember that the satellite capability to search for those 121.5 beacons ended in February of 09. So it probably is time to upgrade to that 406 beacon. You think about it, a 121.5 beacon with that kind of accuracy I mentioned before, it gives about a 780 square mile area for search. But the 406 beacon with a 30-meter precision GPS accuracy, well, they're going to come find you very quickly out there. So let's talk about the basics here of what I tried to cover tonight. Prevention is vital in that you need to make sure you do the maintenance on the aircraft and make sure you keep enough gas in it and know how to get to the fuel from your fuel tanks so that you don't run out of gas. Make it a rule, a good technique, to land with 1 hour of fuel from every flight. Just don't push it to 30 or 45 minutes. If you have a problem, yeah, you're going to follow those 3 rules: aviate, navigate, and communicate, and do it in that order. And now that we've talked about it, I wish that you would go through and have a plan and go out the next time you fly and actually practice it. Go up to about 4,000 or 5,000 feet and give yourself an engine failure. Well, let's simulate it instead. Simulate that engine failure, practice your plan for a restart, finding an adequate field, simulate calling the Mayday and declaring an emergency, and then see how you do with taking the aircraft at an appropriate speed down to a reasonable landing spot. Remember that if you have a plan, it's going to keep you under control. I would also suggest when you finish with that high altitude practice, go and do a low altitude practice as well. It'll give you good experience for if that opportunity ever arises. When your engine fails, you'll know what to do. All right, that's all I have for tonight. I've got a quick view here of the poll that says that 15% of the people responded yes, they had engine failures. And we had about 83% polling. That would lead to about 350 people polling. And that's a lot of engine failures out there. So that's all I have for the formal presentation. I'm going to give it over to John and questions and answers.
All right, thanks, Sam. We've got a lot of good questions tonight, so I'm going to roll back up to the top here, and we will we'll do that. Let's just come here. All right, so we're going to go through the questions that have come in. First one, a really good one. This came from a gentleman early on in the presentation. I fly a 1940 model aircraft. There is no airplane flight manual or pilot operating handbook. Therefore, there is no spec best glide speed. Would trimming completely nose high get close to the best glide speed, assuming a complete engine loss?
That's a really good question. And I have no idea. I'm sorry, I do not have an idea if that would be accurate or not. Now, we'll tell you on a 172, if you have an engine failure, if you trim full up, it will give you generally about 65 knots. But I do think that the manufacturer's trim capabilities do differ quite a bit. John, you may have an idea or
the only thing that I could come up with would be to go out and get up to altitude and practice gliding descents at various trim settings and see if you can arrive at one that gives you your best glide and your best rate of descent over a period of time, and try to see if you can go a certain distance. Maybe use a GPS to try to track that, but it's going to take a little bit of work to do that. But I would suggest maybe taking a look at was it Flying by the Numbers, I think is there's a book Richard Taylor, I believe it was, wrote a while ago that talked about that. Maybe it was precision flying. In any event, you could go up and you could test that and see how that goes.
I would say also the possibility is there are probably owners groups for your particular aircraft. You might want to go out and chat with them about it. And finally, you can do a closed course, basically using a portable GPS to see how far you'll glide from 5,000 feet down to 3,000 feet or 2,000 feet distance-wise to a point, and then reverse it and go the opposite direction to negate the wind factor. And that may give you an idea of what the best glide speed would be.
Yeah. Yep. Another question related to glide. In managing your glide on approach to your chosen landing site, you can increase descent rate by going above or below V glide or best glide. Is it fair to say that above best glide is great if you're landing on a long runway, but below best glide is the better option if you're going to land in a smaller field?
If the question is trying to reach the field, then you want to be at the best glide speed. Now, faster or slower will hinder your ability to go the distance to that landing field. Now, if you've got that field in sight and you're trying to land on that field, the best thing for you to do is to be able to land on the clearest surface within that field at the slowest practical airspeed. I think that may answer the question.
Okay. All right, and then talking about the impossible turn or the emergency turn back, a question was asked about wind during the emergency turn back. Should you turn into the wind? Should you turn away from the wind? Is it going to make a difference? Are you going to end up landing with a tailwind? Is that going to be an issue for you? It's kind of a multiple question there.
And that's a very good point. I wish I had thought about bringing it up. I always brief immediate turnbacks by turning into the wind. And the reason I want to turn into the wind is that it's going to minimize the radius that I maneuver away from the airport landing surface and keep me closer to that landing surface. If I turn with the wind, by the time I roll out after turning 210 to 240 degrees, I'm actually further away from the airport than I would have been if I'd turned into the wind. The landing downwind, well, yeah, that's a problem. But if I'm at low altitude and having to perform this immediate turn back, my first priority is to make sure I get to a reasonable landing surface and then slow and land as slowly as possible.
Okay. We have a question here about deploying a ballistic recovery system at a very low altitude, say 500 feet AGL. Is that a good idea or a bad idea?
You're going to have to refer to your aircraft operating handbook, the pilot, the operating handbook, the manual, to determine what the minimum altitude is for ballistic systems. I do not have that information for your particular aircraft. I will say that ballistic systems have saved a lot of lives. It doesn't mean you're a lesser aviator if you use them. It just means that you're in a situation where you need to take control of the situation using the safest means possible, and that may be deploying the parachute.
Here's another question for you. What's your general recommendation for an engine failure over forested mountains as we find in the West? And part two, if you add the ability to bail out, say you're flying an aerobatic airplane and you're wearing your parachute that day, should the pilot bail out or try to land in the trees?
Okay, you bring up an interesting point because you may have noticed some of the hesitations during the webcast, and that's because I loaded the wrong presentation. I had several other slides that addressed terrain in my primary presentation. So when they didn't show up, I was kind of surprised. But I did address this earlier. So what I do is I look at terrain functions that are available on almost every electronic source out there. Avidyne, Garmin, you name it, ForeFlight will all have terrain functions out there. If I am at night, IMC, when I cannot see the terrain, I'm going to turn to parallel ridge lines. I'm going to find a valley. I'm going to fly to the bottom of that valley, and I'm going to try to land parallel to the ridge line so I don't have terrain rising up to meet me. Now, when it comes to trees, I'm going to flare the aircraft into the tops of the trees, just like I mentioned before, as slowly but controllable as possible, just to allow that energy to be dissipated, and then take my chances as the aircraft settles into the trees. With your question about whether to bail out and land in the trees versus land the airplane, if you think you have a reasonable area to put the airplane down, meaning relatively low trees, I would take that option. If you come down under a parachute, chances are you're going to survive that, even if you're stuck in a tree. So I'm afraid that's going to be personal preference for you. I've jumped out of airplanes a few times, and I think I might take that option.
Okay, and then a comment related to that was keep in mind that quote unquote open fields may appear available in certain hilly or mountainous areas, but as you get closer to the field you've selected, you realize there are actually clear-cut acreages within the forest, and there's 2-foot tall stumps in there. Not really any way to avoid that. At that point, you're probably pretty much committed. You're just gonna have to do your best to avoid the stumps as you land in there. But
that's a great observation, and that's not a good case. Clearly, you want to avoid those stumps.
Right. Here's a question related to flying with an operating ADS-B out. Does the FAA, with an operational ADS-B out unit, will they, or the U.S. Air Force Rescue Coordination Center, be able to track you to your forced emergency landing?
The word I got is that ADS-B out helps tremendously in terms of following your aircraft, even if you do not have flight following. So I think the answer is yes, ADS-B out is going to remarkably help everybody should they have a forced landing. I would also suggest, and I didn't mention this before, with the cell phone forensics capability of the CAP, I would suggest leaving a phone on, not in airplane mode while you fly. It may suck up the battery a little bit searching for towers, but if you have a forced landing, even if you're not able to use that phone, if you're within any kind of cell phone tower, the CAP can narrow down your position from about a 1 to 2 mile grid ping that the cell phone owners or the companies provide, and they can narrow it down to a very close proximity, a very good location.
Okay. Here's a question related to your comment earlier about using halon. Doesn't halon evacuate oxygen? Should that be used while you're trying to breathe in the cabin?
Halon is not compatible with humans. You're absolutely right. Fire is also not compatible with humans. So I am going to take the greatest emergency first and try to treat it. And I think those small fire extinguishers that we carry in the aircraft probably don't contain enough halon to cause me permanent damage. I would rather put out that fire and bang the window open or knock the door open with that empty fire extinguisher than not use it at all. That's just my opinion.
Okay. Here's a comment from another gentleman. I fly over a lot of trees and lakes and swamps in a Piper Arrow, a retractable aircraft, no beaches. Which do you choose? Strategically aimed treetops, wheels down, or water, wheels up? In either case, open the door.
I personally would choose water, wheels up.
Okay.
Because that's more controllable than landing in the tops of trees. The number of ditchings that are successful are huge. I don't remember the statistics right off the top of my head, but it's upwards of 88 to 90% successful with no fatalities system-wide. So that includes fixed gear aircraft. So it's a very successful tactic.
Okay. Here's a good question. What about engine shock cooling while practicing in-flight engine failures? Any recommendations there?
There is a bit of debate regarding shock cooling, and it's probably not worth going into here. I will say that if you're nice to your engine and practice it a few times, you're probably not going to cause a deleterious amount of wear and tear on your engine. If you're doing it from high power all the way to idle, and you're doing that 5 times every flight, it's probably going to be not good for your motor. That's all I can say on that one.
Okay. Here's a question that I'll answer, and it was, does the AOPA have a list of recommended grab bag contents for a ditching or emergency landing? And I'll point you towards the Air Safety Institute website and to our Survival Safety Spotlight. You can find our information there. Plus, there are a number of articles that are written and available out on the internet about that as well. Keep in mind, you always want to have something that's going to give you some sort of shelter, something that's going to provide a way to signal, also something to provide some rudimentary first aid. And I will add this, that any training that you can take does not add to the gross weight of your aircraft, and it resides in your brain housing group. And if you can remember that, then go ahead and do it. And I would highly recommend taking any kind of a first aid course. Wilderness first responder would be a very good course to have if you do a lot of flying over backcountry or in the backcountry. But you know, anything that you can take is good. You can toss a Boy Scout handbook in the back of your airplane if you want to, as a kind of a coverall for that. There's a lot of good skills that are in there, but just having the book along doesn't mean you know what to do. You do have to practice it. So get the training, practice, and then go fly and have fun. I think we have time for probably one more question here, and we've got a lot to choose from. Two tips to pass on with a constant speed prop. If the engine quits, immediately pull the blue knob all the way out. Then zoom climb to ideal glide speed trim and problem solve. Your thoughts on that?
Oh, well, that's a very good point about constant speed props. Yes, to maximize the ability of the aircraft to glide, you want to reduce the drag, which means you want to bring the prop all the way, control all the way back to the not quite feather position, but the higher pitch. The other thought about zoom climb, there's actually not a lot of valid documentation that says zoom climbs actually help. If you're able to maintain your altitude while you decelerate, it's still going to give you about the same distance of glide range out there.
Yeah. Okay, we're going to end the Q&A right there, and I'm going to talk a little bit. We talked earlier at the beginning of the webinar that if you signed up for the webinar using your FAA-safety.gov Wings account email address, Wings credit will automatically be applied to your account. If you haven't done that, you'll be receiving an email from us here within the next few days. You can respond back to that, and that will come into our office. We'll take care of it. Just let us know what that email address is, and we'll take care of adding that to your Wings record. For those of you that use the AOPA Pilot Passport, this is a relatively new feature of, well, not relatively new, we brought it out last year. It is a way to earn points and badges for doing all kinds of wonderful things, visiting airports, going to fly-ins, going to aviation events. You can check in and you know, collect an entire state, collect an entire region. You can go to grass fields, towered fields, Class B, Class C, you name it, it's in there. We're very happy to provide you now with a badge in the passport for attending ASI webinars. Not only do you get the badge, you also get 1,000 points that go towards your total overall score, moves you up on the leaderboard, hopefully. And I'm going to show you a couple slides here how you can do that. Do copy down this code here, ASI Web 082720. You'll be able to add that into the affiliate code section, and you'll be able to redeem that badge. This code is only open and available until September 10th, when we have our next ASI safety webinar. So let me show you how to access that. First of all, go to the AOPA app on your device. If you don't have the AOPA app, you can download it from the Apple App Store, and I think it's also available for Android devices. But in the upper left corner, there is a menu. Just go ahead and tap on that, and that will open up the main menu for the app. You'll see Pilot Passport at the very top. Tap on that. Then you'll see My Pilot Passport, tap on that, and that will bring you to this page, My Points and Badges. If you go down to the bottom of the page, there's an area there that says Redeem Affiliate Code. Go ahead and tap on that. And then you can enter the code that we just showed you, and I'll show you again here in a few seconds. Enter that into the Redeem Affiliate Code. Click on the Redeem Code button, and you've got it. So remember, redeem the badge by September 10th, 2020, when you'll have another opportunity to redeem a September badge. And again, this is the badge that you'll see, ASI Web 082720. And just go ahead and enter that in the affiliate code section. Hopefully all of you are AOPA members. If you're not, I would encourage you to consider joining, particularly if you like this webinar. One thing that you should know is that none of the cost of this webinar was paid for out of member dues. All of the Air Safety Institute's operations, whether it's safety seminars, webinars, YouTube videos, any of that, that is done through the generous donation of pilots and aviation enthusiasts like yourself by donating to the AOPA Foundation. And you can go to aopafoundation.org/give to make a donation if you like that. Our next webinar, as I mentioned, is on September 10th at 7 p.m. Eastern Time, and we're going to present Sightseeing Safely with Jason Miller of the Finer Points. As I mentioned earlier, you'll receive an email from us with a link to a recording of this webinar and also a link to register for that September 10th webinar. With that, I want to wish you fair skies and thank you and fly safe.